All right, we're recording. Okie dokie, artichoke. So then, I know I haven't gotten your test marks back I'm working on. It's actually the thing that's currently the top of my stack of things to do. Even before making a test for another class to do. So, the tests will be marked, I hope, by the end of today, with hopefully the grades being entered by the end of today as well. We'll see how it goes. There has been a change in the policy with respect to the tests. This may have happened because, basically some professor broke rank and released their, let the people have their tests.
There was no grade. There was no grade.
On the tests?
I emailed you about this over the weekend. Someone, I don't know who, just simply released the midterms, but they didn't give a grade. It just gave me the
No. This is what so they're all sharing a common course shell, right? So basically, someone, I'm not exactly sure who, released their grades, but that published everybody's grades.
I see.
So now everybody can see whether or not they've been marked, basically. That's the situation. And y'all have not. So I'm working on it. But yeah, so that's the situation with the tests.
Do you know when you're marking, are you going to give us any part marks if we tried something but then you only get when you run it on the system?
Yeah, generally I give part marks for not, for having the right idea type thing. What you don't get any marks for at all is if you have the wrong idea, which does sometimes happen.
Probably.
So yeah, basically, the tests are in process of completion. Right now, I've got 2 questions left to mark, and then I'm going to be doing the totaling, and then I'll be entering the grades, and hopefully I'll be able to get that done today. But yeah. Anyway, long story short, the policy has changed, and the tests will be distributed back to you folks. Therefore, I will use sometime next class to review the tests.
Awesome.
So I will bring the tests next class. You can grab your test, and then we will go through the test, and then I can complain about people's questions. Except my own. My question was perfect. There were no flaws with it. Of course, I haven't marked my question yet.
I agree with yours. Yours was the most fair.
Thank you. Mine was the long question at the back.
Yes, I liked it.
Yeah. I mean, it was the worst one because it was the longest one, but
It was, yeah.
I didn't expect you to know what printf was and did without ever having been taught printf really, or being expected to use it. So,
But you've always told us not to use that. We should use echo.
well, see, it has its uses if you want to do particular things with formatting, but it's a bit archaic and more suited to other lower level languages. But
Okay. So that was why, most of it, when you were saying that, I just used echo because I always had that knowledge in the back of my mind that you said don't use this.
well, it's kind of interesting because the reason that it had to be printf there, basically, is printf actually does trip an error if you try to print something as a string that's not a string. So it was kind of a way of like getting around PHP's weak typing to
Oh,
be able
okay.
to do a weak typing question on you with a string. It would have been so much easier to just use an integer for that question, in my opinion. But yeah, basically, it's kind of funny removing the error. If like all you were going for was removing the error, changing printf to echo would have done it. But the problem is that the question was like, use best practices. So the expectation was that you would use filter input.
Yeah. The,
So, but anyway. So today we are meant to be talking about security. This is the worst keyboard trade in the college. It's terrible. Alright. So, we've got two main topics to cover. The first is hashing and assaulting, and the second is the SQL injection attack.
Are we still in databases and web applications?
We are very much still talking in databases and web applications, yes. These topics have not, the HTML, it hasn't been published yet. Are you looking at it?
Well, I'm just looking at,
Can you go back to the module? Scroll in. Let me see if. Yeah, Steve has released them, yeah. All right. Steve! Steve!
you're like the crowd from the Steve Wilkos show.
Yeah. Basically, I'm going to be teaching you stuff, and the like HTML like slides page on Canvas will come sometime this week. Probably sometime today. So let's talk passwords. All right. Last time in class, we did this example where we had a rudimentary login system. Let's talk about how we can improve the security and safety of that login system and login systems in general, right? So, when we remotely access a database, that database is a separate point of entry to try to compromise the system, right? The database can be compromised without your PHP scripts being compromised, right? So the Apache stuff, the stuff that we've been learning in this course so far, that's a separate server, right? The database is another server that's also vulnerable to attack, right? So we never want to store sensitive information in a database in an unencrypted way, right? We wish to encrypt the information in the database so that only we are the ones who are able to read it. Even like, it's again this multiple layers of security thing. You should have walls behind walls behind walls, right? It's quite a bad thing if somebody manages to get access to your database, but you can mitigate the problem by using encryption, but also using hashing. So what is hashing? Does anybody know what hashing is? Any idea?
It's like splitting bytes. I don't know the specifics. It's like parsing data based on bit sizes.
Parsing data based on bit sizes. You're describing one of the sub-operations inside of hashing. Yeah. Question, or, yes?
It's just like a way of encrypting your data.
It's a way of encrypting your data, that's correct. Anybody have a more specific definition? Okay. So, hashing is different from encryption, right? If you have encryption, it's not a million miles away from JSON encoding, decoding, sort of in principle, right? You have data that goes in. The process of encryption produces a scrambled version, right? You know, like or you replace that with like a percent sign. Yeah. The data becomes randomized. But with encryption, there is a similar process called decryption, where the data can be restored.
Nick, I think you've gone off camera. You're off the camera.
I'm off, oh, yeah, okay. Copy, paste. Yeah, so
Yeah.
I'll do the rest on this bit. So you encrypt to scramble the data, then you can decrypt to unscramble the data. Both the encryption and decryption process require what is called a key, an encryption key. Right? This is like a secret code. Both the thing doing the encrypting and the decrypting must have the same key in order to decrypt the data correctly, right? So let's say that this is a client-server communication, because we know that the payloads in HTTP packets are encrypted, right? So if this is client, this is server, and this is the internet, right? The client encrypts the packet, sends it through the internet's infrastructure. This cannot be this information cannot be decrypted without the encryption key. The encryption key does not travel with the HTTP packet. Otherwise, there'd be no point, right? If you could get the decryption key just by reading the packet, you know, it doesn't work that way. Once it arrives at the server knows the decryption key. This is more like on the networking side of things, but essentially, the client and the server have a number of different communications that they exchange where they establish what their shared encryption key will be, right? I believe this is known as handshaking. So, I could be wrong about that. I'm not a networking specialist. So, the process of hashing is a one-way encryption, right? Hashing. You have your password. You hash it, and you get some scrambled garbage, random numbers and letters. Human beings are bad at coming up with random stuff. So there you go. I need one more character. Q! Wonderful. So, in hashing, there's no unhashed process. Doesn't exist, cannot happen mathematically. So there's no going back from hashing. Once a password has been hashed, it has been hashed permanently. The trick is something will hash to the same hash value each time. It depends on what the hashing algorithm is. So when you study this, when you study hashing in your data structures and algorithms course, as I hope you will do, this is how hashing works, right? And it's kind of, it's an argument that takes place on the number of possible, you remember how we were talking about entropy earlier? Like in the last couple of classes? We talked about entropy, right? Password entropy? Maybe?
We talked about like
Can you give a
32-bit encode.
Yeah.
Can you give a refresher in technical words?
Yes, I can give a refresher. So
Summarize that area of the brain for a second.
the number of possible passwords is the entropy of that password system, right? So it's the number of allowable characters to the power of the number of characters allowed, right? So you have a space of possible passwords. You are mapping that space of possible passwords to a smaller space, which is the hash values. So, you know, if you had 64 bits of entropy in your original password space, and you hashed that down to, you know, 32 bits in your smaller area, right? Basically that means if you were hashing perfectly, each hash value would have 2 passwords that would generate it. Right? Now this isn't a problem because user accounts are generally allowed to have duplicate passwords, right? It's not really it doesn't really matter if, you know, user C and user D both have the password fuzzy pickles. It doesn't matter, that's not a security problem. So it's also not a problem if the password 1, 2, 3, 4 and the password 5, 6, 7, 8 both hash to the same value, right? In your table, user A, let's say the value hashed here is 7379, right? Both user A and user B would have 7379 in their password table, right? They would just show up as a shared password, no particular, like it's not a problem. But the reason hashing is a one-way operation, assuming you know the hash code, right? Which of the 2 of these entry points was the correct one? It's mathematically impossible to determine, right? The way that hash functions achieve this is normally using our old friend from Intro Python and Java, the modulus operator. So, basically, this is how a hash function generally works, right? First, if it's a string, you need it as a number. So you have to have some kind of way of converting the password as a series of characters into the password as a big number, right? Fortunately, it already is a big number because it's a series of ones and zeros. But just for the sake of argument, let's say our particular hashing function takes the sum of every character interpreted as a number, right? So if we have a password called pass, right? The first thing that we would do, get the ASCII values.
I think small
So-
is 63 or
Let's say, oh, someone faster than me? P is 112. 112. A is,
I think 63 or 67, I can't remember.
where are you, A? There we are. 97.
Oh, close.
S, 115, 115.
Oh, this for, math, right?
You could then compute the sum of this, right? Which I'm not going to do in my head because I don't want to embarrass myself. Even though this is technically the sort of thing that I should be able to do because I have proper education.
Information, am I right?
Hmm? Yeah. I was also ruined by calculators. I wasn't ruined by calculators until 7th grade though. So, 439, right? We then need to know how many slots there are in our hash space, right? This is very similar to how a hash table works, except in a hash table, this thing's basically quite a large array where each of the hash values is an index of that array, right? So let's say, just for the sake of interest, that we have 13 possible hash values, right? Well, the easiest way to take this number and assign it a number from in here, right, is to say 439 modulus 13, right? Now, Mr. Google, are you going to let me do a modulus? Ah, there you go. So that comes out to 10. So the hash value for this password would come out to 10 in this extremely simple scenario, right? Again, it doesn't matter in this case if multiple passwords hash to the same value. But, and also there's a reason I picked 13 here. It's not because it's my lucky number. It's because it's a prime number. Hash values, hashing, whenever you're choosing one of these, the number of entries in a hash table should always be a prime number, for various reasons that relate to, like often you won't just directly put it in, you'll often hash it among two different modulus values, and if both of those are prime numbers, it minimizes the number of like repeats and overlaps that you get. So it basically, it scatters the data optimally to use prime numbers for this. So, good. So this is the process of hashing. In general, the the larger this space is, the less guessable your passwords are, right? So at 13, should take 13 guesses to get that, right? The way that passwords are currently, like the current trend in them, is to use 60 characters, but hexadecimal encoded, right? So, how many digits can you express? How many values are there in one hexadecimal character? 16, precisely. So, what we in fact have is 16 to the power of 60 possible hash values for your sort of, let's say, the default password system that we're going to learn about that's in PHP, right? So 16 to the power of 60 is going to be quite large. 16 to the power of 60. It's 1.7 times 10 to the power of 72, which that's quite unguessable. It would take a very, very long time to guess your way, brute force your way through that. Assuming you were allowed 1 million a second, it would still take longer than the universe is old by quite a considerable margin. Once you get into numbers in this range, it's like if you had one attempt for every atom in the universe, and inside of every atom in the universe there was another universe, and you got one attempt for every atom in that universe, and you did that like 4 or 5 times, that's like the number of guesses that you would need to guess the password reliably, right? But you could just get lucky.
BOGO sorted.
Yeah, exactly. Well, BOGO is probably the best sorting algorithm
Yeah.
for an array of size 1.
Thank you.
There you go. It's okay for an array of size 2, but I wouldn't use it for an array of size 3.
Mauricio, the most reliable and most fast is that one.
So that's quite unguessable. That's how many characters passwords are hashed into. But this is the principle, right? That's how a hash works. Any questions about that? Okay. So here's the issue, though. All right. Here's an issue. Once again, we run into the problem of human fallibility and human beings being the worst things and not really suited well to existence in cyberspace. Cyberspace is not the environment that human beings evolved in, right? We're not well suited to it. People often choose common passwords, right? They often share their password among multiple sites, and, the manner in which passwords are hashed has to be a secret, right? So, basically, a thing that has become common practice on websites in recent years is a process known as salting the password. I'm not sure where it got this name, possibly because it makes hackers salty. So, the process of salting is to take your basic password that, people use, and to add a number of characters to the end of it, like pass, I'll do it in a different color. My site is cool. Where the server adds these additional characters to the password, but prior to the hashing process, right? Now this is the old way of doing it. So, in essence, the way that this idea started was that you sort of picked a secret passphrase for your server, and the hacker not only had to guess a correct password, but also whatever your passphrase is on the server in order to be able to successfully, and also to know your hash function, how your hash function works in order to hash your password and be able to look up a username.
So essentially, it's like having a password by the user, the encryption mechanism on your side, and also something that the server side is by.
Exactly. The server is adding its own password to your password to make your password stronger.
Could be a string of commas and like numbers and like a modular symbol, and it will never be like guessed.
So
Let's say, let's imagine.
a well-written hash function, if you add even a single character here, you get a completely different result in terms of hash value.
Okay.
right?
Okay, yeah.
So it doesn't require much salt to completely scramble the password.
Just enough salt.
Yeah, like 4 or 5 characters is more than enough salt, right? So we're kind of getting into these are techniques that you don't necessarily have to know how to perform explicitly, but you should be aware how they operate on a theoretical basis. You should know what PHP is doing. This is how this idea started, but obviously it's not good to have one salt for every user who uses your website. That's very guessable, right? That kind of defeats the purpose to an extent. So, what happens now, PHP generates a random set of characters. And slaps that on the password, right? In theory, you can always still add your own salt if you want to, because you have control over the string that's read from the user. You can always add your salt before you use the password hash function in PHP, right? But salting is performed by password hash by default. It used to take a parameter with what you wanted the salt to be, and as of PHP 8, if you provide that, it just ignores it and provides its own random characters anyways. So
Why would you want
yeah,
Why would you want the random password that you're creating to have a possible traceable seed of how it's being created?
exactly.
Why?
Yeah, it's just kind of funny that it gave it to you, and that's okay, we'll leave it in there for compatibility, but we're also going to ignore it if it happens. It's I don't think I've ever actually encountered something in documentation of a programming language where a function has said, this argument will be ignored for safety reasons. We're ignoring you completely, this argument.
It's the programming language equivalent of an appendix.
Yeah, exactly. It's only there for evolutionary reasons. Or the little toe. I swear that in 100 generations we won't have them anymore.
Hopefully.
Yeah.
I smashed mine yesterday in the door.
Oof, terrible. So that's how salt works. Now you may ask the question, okay, sure, but doesn't that mean that PHP is keeping a secondary database of all of the passwords that are being entered? Right? Which it kind of does actually, right? Because if the salt is different for every password, then it, like, you have to use the same salt anytime that password is entered, right? Otherwise, it won't hash to the same value. So, you know, between sessions, between days, between weeks, months, years, right? The password must have the same salt applied to it, unless the database is also updated to, like, if you want to update the salt, you also have to update the database entry, right? Because updating the salt will make it hash to a different value, and recall that this is the number that's going on in SQL, right? We're trying to match this to the SQL value, right? I'm getting funny stares.
I'm so lost as to where we are.
You're lost? Okay, I'll back up. Where were you previously not lost?
Okay, so we have this string that is one-side coded, so only one entity knows what it is, and we're using it to encrypt a password or a passcode, essentially, and then we're providing that to the client. So the server is generating this string, and
It's not being provided to the client.
so, okay, yeah, you're right. So the client is using it, like, that's where I'm
All right.
losing. You know what I mean? Like, what's the use for it?
Okay. I'll do an overall, okay, anybody need this? I'm gonna erase it. Okay, all right. So this is the process then. So, we have the client. Client has a web form. They enter their password, fruit, exclamation point 7. All right? That gets sent to the server. What type of packet? Or what type of request?
Post. It's post.
Never get. Always post for a password. Post puts it in the payload, which is encrypted. If you put it in a get packet, then everyone can see the password,
Indeed.
right? And it doesn't matter if you're salting it later. That would, like, putting this in a get request would break the whole system, and it'd be fully exposed. So, we send it via post request to the server. The server, we say, you know, password is equal to filter input, filter, there we go. Input, ... right? So we receive the parameter, right? The next step is we would compute the hash. So hash is equal to password hash pass. So right now I'm breaking down the structure of this function. So the first thing that it does, right, is it salts the password. Salt password. In order to salt the password, it must look up password in internal database. The salt changes the hash value, right? If I have salt A and salt B in the same password, I will get two different hash values, right? this guy is eventually going to be used, you know, to do an SQL query. Right? We eventually send this hash to the database server in order to perform an SQL query to see if the password matches the username, right? But in our SQL, right, in our database, we no longer have username and password, right? We're not storing passwords in plain text anymore. We are now storing hashes, right?
So you're encrypting it on the database so that if someone got into the database, they would be able to read it? Is that why?
Precisely.
Okay.
That is the whole point,
Alright.
yeah.
It's an enclosed environment. Everything that's needed, it's within, not without.
Yes, everything is hermetically sealed. So, basically, so PHP and the Apache server need a way to reliably get the same salt for a specific password. So it keeps an internal database like that for this, the same way that it keeps an internal database for currently running sessions, right? Except it's much longer term. Salts can be updated, but updating a salt requires updating it in the SQL database as well, right? Because, you know, if let's say the hash here becomes 7, right? The database entry is going to say 7, right? If we change the salt, this might hash to like 18 or something, which means you will no longer match what was in the database, which means it would come out as an authentication error. It would think that you entered the wrong password, but in fact, you just salted the password incorrectly, right? So it needs to be able to give you the same salt for the same password every time.
So the salt acts as the key in this context? You're saying if
It
you-
functions like a key.
Like,
Yeah.
that's what it sounds like when you describe
Yeah,
it.
it functions quite a bit like an encryption key. If the same key is not used both times, then you're going to have an incompatibility, and you're not going to get the information you want.
And that's not something that's entered manually by us?
What the salt?
Yeah.
No, not anymore. Not as of PHP 8. But I ask you, what version is running on CS Unix?
Definitely not 8.
7.2. So let's take a look at the PHP documentation for the password hash function. There we go. So the password hash function creates a new password hash using a strong one-way hashing algorithm. Because this is so commonly used, you can assume it's good.
Yes.
If somebody cracks password hash, the whole internet has an issue, not just you. So it's kind of like you got bigger fish to fry at that point, you know? Question?
So it's all one algorithm it uses, just nobody knows what it is?
Oh,
Or is it changed?
No, it's definitely known what it is. That's like, these algorithms are written in such a way that like,
They're predictable, if you know what, they're predictable to a certain degree, I imagine.
well, like scientific papers are written on what good hashing algorithms are and why, and like you can pick apart the algorithm in the process of a scientific paper, but it basically takes the ability to read a scientific paper to understand what's going on inside the hashing algorithm. So like, to an extent, it's like, it's kind of like with encryption. The encryption process itself does not give you the security. It's the inputs to the encryption process that give you the security, right? Does that make sense?
Yeah.
Like the encryption key is what is providing the security, not the algorithm itself. The same thing with hashing, right? Yeah, basically. So, in general, you can assume things are configured correctly by default. Question?
Sorry. So basically, what you're saying is like it goes from salting first, then hashing, or
Yes, it has to salt before it hashes, right? Salting is the process of adding things to the password, right? So here, if my password is this green coming through? Can you read that? No? Alright, I'll do it in blue. I don't even know why I have a green marker. Fruit 7, or is that fruit exclamation point 7, right?
Sir, do you have green markers so red doesn't feel that useless?
I mean, red is occasionally useful. I think it has better visibility than the,
Yeah,
Yeah.
yeah.
maybe, let's take it, do a test. Oh yeah, red is way more visible. Okay,
Go back to explaining, sir.
sorry. Basically, you take the password and you concatenate the salt. So that you get the new password, fruit, salt. Right? Obviously you wouldn't use the actual string salt, but this is the idea, right?
yeah.
That is what gets hashed. Hash this. Right?
Okay. So then, like, I'm guessing for the salting now, it can happen at the end or at the end of the password or even at the beginning of the password. Doesn't really matter.
Correct. Yeah. Yeah, you can have the salt prepended or appended. It doesn't really matter the placement. It will equally scramble the hash code of the password no matter where you put it.
Okay.
Right? It's just the fact that you added characters that scrambles the hash code. Right?
Mhm.
So, okay. One further explanation about why salting is necessary, right? People use sets of common passwords, right? People use sets of common passwords to such an extent that hackers have a group of common passwords, right, which they can use to try to guess what the hashing algorithm is, or guess what the inputs to the hashing algorithm are, right? So this is called a rainbow table, actually. So if you salt the password, the hash values get scrambled, and rainbow table attacks are no longer you're no longer as vulnerable to them, because you're not just working with a pure, this is the only input to the hash function, right? there's also a randomized input to the hash function, which breaks it up and makes it different, scrambles it. Make sense? But any more questions? Is everybody working on an assignment for another class? No? So, you'll notice here that options includes the salt. I'm not sure what cost means in this context, but so you used to be able to provide a salt as an optional parameter, but warning, the salt option is deprecated. It is now preferred to simply use the salt that is generated by default. As of PHP 8.0.0, an explicit given salt is ignored. There you go. So the salt is ignored if you provide it. Sound good? But of course, that is PHP 8. CS Unix is running PHP 7. So if you provide an explicit salt in CS Unix, that will actually be used. So you can just have your own little password if you want. Make sense?
Sir, question.
Yes.
Was the salt given as a parameter, was it like a specific value that would be applied to everything, or would it be something that would get scrambled and given to everything?
Well, it would all depend on how the user, or how the programmer, the server-side programmer would want to do it. I guess you'd call them back-end developers, don't you? Yeah, so obviously the easiest way to do the salt is to just pick a phrase, pick a group of characters, like your favorite baseball team or something, and then append that to every password incoming from every user, which is kind of funny. Or you could think of other ones like I'm an idiot, put that on everybody's password. You could have some fun with it, but it's less secure. That is still improved security over not salting, right?
Yes.
But what it means is that the hacker only has to guess your password, right? The one that the constant that you set down in your PHP file. And if your PHP source code is ever published, which hopefully it's not, but published, if you're ever subject to corporate espionage, let's put it that way, then anybody who got a sneaky little screen cap of your PHP script would get your salt, and then they would know what you were salting your passwords with, and then they could just use a regular rainbow table attack, but using pun passwords plus your salt. They would also need to know if it was at the front or the back. But yes.
So if you guys see our PHP on our CS Unix when it's born, then how do you tell that the PHP that we submitted to Canvas is the same as the one that we submitted to CS Unix?
That's an excellent question. You can't see through the browser, but so I might perhaps be telling them a bit too much, but here's how it works. Basically, instructor account privileges are elevated, right? So I not only have, I don't only have the ability to view my own account. I have the ability to view everyone's account, to grade them, right? That means that I also have shell access to all of your accounts, after a fashion at least. So basically what I've been doing is I've been using a program called curl, which is a Linux utility program, to download the remote copy of your PHP to my own system, and then I run a diff comparison on the version that you submitted through CS Unix to see if there are any differences. And most of the time it's just somebody didn't get most of the time it's just like the line ending character or the file ending character is different or wrong, which is not actually a problem because you know, different editors, whether someone's like made it on a Mac or something, that'll throw that off, but, occasionally people do try to like sneak in a few sneaky bug fixes, and, you know, like little stuff, like one or two character differences and that sort of thing. But this is because I wrote like my own super awesome, amazing grading script that I'm now using. It doesn't actually, it doesn't like interact with the rubric on Canvas, unfortunately, so I still have to like click all the boxes manually. And it doesn't tell me what I should grade you at. All it does is it just reports to me the information relevant to the boxes I should select, like, did you change your Canvas version, you know? I can like do a grep search for keywords to see if you're, you know, in JavaScript I would like check to see if people were using inline styling just automatically, so I didn't actually have to look, you know? Because who wants to read every single bit, right?
Who wants to read something that cannot be that can be automated?
Well, this is why we have search functions, you know? If you know how to use regular expressions, you know, use it.
If you are told to use certain function in order to actually get the grade, just implement a function, you know?
Precisely. I'd like to whip up a new version that like gives me like a quick report on how good your commenting was. Like, whether you commented every function you should be able to write a regular expression for that.
Yes.
So, I haven't got that far with it yet though. So that's what I do, is I use elevated account privileges to yoink a copy of your PHP from your account on CS Unix automatically using a script. That's how I do it. Incidentally, since I wrote that script, I also haven't been grading you on CS Unix. I've been grading you in Accent. But I made sure the version lined up, so yeah. Although my script has like the option for both, so all I have to do is like set a flag at the top, and it'll either load you from CS Unix or from or just load you on my own system.
Imagine CS Unix updates, and now that the flag is just usable.
Oh, no. It'll be fine. They never update it.
No.
Yeah, no, actually there's a reason that I do that. The reason that I prefer to do it on Xampp is because I also, for assignment 1, I haven't written this yet for assignment 2, I had my own test bench website that I plugged your PHP script into that gave me like side-by-side comparisons between what your output was and what the expected output was for like, I ran like a dozen tests for like the serial numbers, right? So, you know, I could have written more test cases, but that was, I think, enough. So I just, if I wanted to do that on your system, I would have to like inject a web page into your CS Unix accounts, and if that process like failed midway, you would like look in your account and see my file that I had left there, which contains all of the test cases I was using to grade you, which in theory is protected information. So that's why I was doing it on Xampp. We'll see though, because like I couldn't get file uploads to work on Xampp previously, so we'll see. I might have to do a grading run on CS Unix for this one. I'll probably just do both. You know, do a combo approach. Anyway, bash scripting is fun, and you should learn how to do it. What were we talking about? Passwords, hash salt, yes. Have we talked about salt enough? Would you like to see an example?
Sure. So for the
Question?
for the Sultan, is it not just creating a random, like doing like a function to just create random characters by the length of what you want, and then adding it to your password?
So it's It's random, but it has to be repeatable. So if it's not repeatable, the hash value you get will not match the database you're looking it up in every time. You need that to be the case, right?
Okay.
So, yes, a random series of characters here is best, but it needs to be the same random characters for every individual password. That's why it looks up the salt, right? PHP keeps an internal database of the salt that it's given to every password it's given salt to.
Okay.
And it looks up what that salt that it used last time was, so that it uses the same salt this time, so that you don't scramble your hash values in a bad way, in a way that breaks your password lookup. Does that make sense?
Yeah.
Cool. All right. Yeah. Okay. So let's. Question?
That internal database, is that like on each server then? Like
I would presume so.
somewhere that, yeah, okay.
Yeah. I'm not sure about the internal mechanisms or workings. Again, this is kind of like networking student territory, but I would imagine it would be reasonably similar to how the sessions database works. That's mostly based on my assumption that people tend to solve problems the same ways multiple times when they have similar problems. Okay. Let's grab XAMPP then.
And then so on. Would that be the one? Or I'll try to put this in there. So you don't add it to stack, right? So something like this.
Also, I know this is like, this should be obvious to everyone. Hopefully this is obvious to everyone at this point. Don't salt in the client. Okay, good, people giggled. Yeah, don't be a salty client. Why? Why don't we salt in the client?
Because people can see what's in your HTML, CSS, JavaScript. It's very open to everybody.
Precisely. If you salt in the client, you might as well not even bother, you know, because everybody can see what your salt is. So, I want to grab the code from last time.
Sir, you sounded like genuinely saddened by the idea that someone would solve on the client.
I mean, yeah, well, see, the thing is,
You don't have to put it.
I just marked a test where somebody tried to use .then in PHP, right? Like, you know that thing you put after an AJAX request?
Yes.
Yeah, so, not everybody in the class, I think, and probably we're talking about people who aren't here, but not everybody in the class has a clear conceptual distinction between the client and the server, despite the fact they're on different machines. So, did you actually launch XAMPP? Kind of annoying how it kind of just sometimes doesn't. Right.
It's always been doing that lately, it just gives up on the first attempt, it only does it on the second attempt.
You know, sometimes they build stuff like this in, It's like, oh, you know, they only really want it if they request it twice, you know? So it's a way to like filter out requests,
I mean, it's like on a mouse, like a double click versus a regular click.
you know? So,
There's no.
so if you want some quick review about how to create a database in my PHP admin, you go xampp admin, database name should match your account name on CS Unix. Credentials, number of columns, let's make it 3, go, bing bang boom, name, ID, auto indexing primary key, good. Password, make that a varchar of at least 60, but the current suggestion from the PHP people is that you should assign 255 characters for this. So let's use 255 characters. Oh, why am I putting password before username? Stupid.
Wait, how are you creating the database again?
So you click new, you select the name. Then you have to click new table and choose how many columns, in this case 3. That will get you to this page.
Just test it.
Sure. Oh man. There we go. Cool. And just for interest's sake, let's insert. Oh man, it's so tiny. There we go. Insert into credentials, values, specify username, password, values,
It's not showing everything. Like all
SpongeBob. Well, actually, this won't even work.
the
You can't create credentials from the database anymore directly, right? Because the database doesn't know how to hash the password you're giving it, and nothing will hash to like the thing I was about to enter. So you can't enter anything from the database SQL pane anymore if you're hashing passwords. So that's fine. Let's set up htdocs with our code from last time. New folder, login, security. Go. So we had index.html, or was it .html or was it .html? Let's see index.html. There we go. We have login.php. And then we had register.php. Contents of login.php. Copy in. There we go. Contents of register.php. Copy in. There we go. So we're back to where we were. Good. And if we take a look at localhost / login security. Oh. I accept the risk. There we go. So, just to remind ourselves what we were doing last time, our register new user button activates our register.php script. This script takes the user and password from the post request. And we do like a check to see if the username is too short, which, okay, fine. Then we create the new PDO object attempting to connect to the database. In my case, it's called Moor, but in your case, you will substitute that for whatever your database name is. Login credentials for XAMPP are root and blank password. We then have our insert command to insert our new credentials into the database. We prepare the command and execute it on the username and password asked through the post request. We then echo success or failure, depending on whether we succeeded or failed. So if we wish to register a new user, SpongeBob password is 12345. Register user. The user was added successfully. So, so I got a question previously in the class. Since pretty much everywhere is salting passwords these days, is it really necessary that we should have strong passwords ourselves? Right?
Two-digit passwords.
Yes. Well, why should we not just be able to provide our username then? Why do we need a password at all? If basically salting constitutes an auto password system.
You need to be able to still be able to access your account.
Yes.
The server cannot just guess who you are.
Yes. Well, again, that's the authentication that's coming from the user, right? If you make your password guessable, it does make it weaker, right? A password, which is the word password, which has been salted, is still weaker than a password that is a good password and hasn't been salted, right? Because if you make your password, what that gives is like everybody, like password is the weakest password because, there's people use it a lot. It's like the first entry in every rainbow table, right? What you're doing is you're giving a hacker a free pass to try to guess what your salt is, right? And if they can guess your salt, your password is still busted. And it also depends on how many salt characters are being added, right? if you're only adding like 4 characters of salt, and the password is password, then the hacker only has to guess 4 characters of entropy, which they can easily do in an hour, right?
Also, can I just point out,
Yes.
the whole, why would you still need a password that will only apply to the really high level stuff when hackers are actually trying to attack the server? People just trying to enter your account the normal way, which is through the actual line, or just move to something, or maybe it's an account that has a credit card in it, they don't need to attack the server, they can just try and bust into the first level.
Yeah. Yeah. Exactly.
Like,
Yeah.
if we're talking about 2 different worlds here, like the people who are actually like entering numbers and random locations into a computer to see if they can break it,
Yeah.
and the people who just want to bust in and grab money. So.
Yeah. Like, it doesn't take a super genius to perform an XSS attack.
Also, it doesn't take a super genius to just find the information and plug it into the front end.
Exactly.
Just take someone who knows where to look.
Yep. You just have to know where to look. So we have our user who has been successfully added. Maybe we add 2 more, SpongeBob, Mr. Krabs, password, are you feeling it now?
It should be money.
Oh yeah, that would, yeah. Oh, user pass, Mr. Krabs, 1, 2, 3. Password is money. Yeah. There we go, successfully added. And Squidward, what should Squidward's password be?
Clarinet.
Bold and brash.
Bold and brash.
Get
Brash, there we go.
Oh, okay.
More like belongs in the trash.
So it'll be like is equal to.
There we go, alright. So, if we take a look at our PHP myadmin, take a look inside our credentials database. Yes, I'm sure I want to leave the page, thank you. You can see, somehow I feel like 1, 2, 3, 4, 5 fits for SpongeBob by default, yeah.
probably Packer.
We have our data entry. But, obviously, these passwords are being stored in plain text. So, let's try implementing hashing. Delete. 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 All right. Now, so we need to hash the thing in both the register script and the login script, obviously, right? So let's start with the register script. Once we have satisfied ourselves that, once we've satisfied ourselves that we've logged in correctly and that the user hasn't entered anything stupid, at that point, we hash. Hash is equal to password hash. Password. Or not that, no. Equal. The password. There we go. Now, let's see, you want more, do you? Password algorithm constant. So, if we take a look at the PHP documentation, password default is probably good for whatever you need to do. So let's do password default. There we go. This function computes our hash value. Now, we use the hash value in our interaction with the database instead of the raw password. And I don't recommend ever doing this, but just for the purposes of demonstration, I'm going to echo the hash.
Is there a point to hashing a password and you're just gonna echo it?
Absolutely not. In fact, this is the worst thing you could possibly do, because it exposes a lot of information about what the hashing algorithm is. In fact, you can probably determine exactly what the hashing algorithm is from this information. So this would completely break everything, but I'm not doing it on CS Unix.
I figure it would be better for the program if you just echoed the password instead of the hashed password.
Oh, this is worse than echoing the password, because you just entered the password. You know what the password is, right? You don't know what the hashing algorithm is, and you could probably figure it out from this information. But like, for our purposes, when we look in the database, we're going to see it anyway. And my point I am trying to make is that it's going to match when you put it in the database. Which, if you know how variables work, you should understand that that would work anyways, but I always like showing that numbers match as kind of a hammer at home point during a lesson, because I'm a teacher, and I teach. So anyway, we're going to echo our computed hash. Do not try this at home. So now, if we try to register our old buddy Squidward, oh, I need a break. But there we go.
Why so long?
Length is security. And that's actually not hexadecimal. That's even better than hexadecimal. That is very unguessable. It's probably on the order of a Googleplex of complexity in there.
I wonder how they got that from just because how many words was your password?
It was like 10 or 12 characters.
So you had a 12-character password and they got pretty much.
Yeah, it exploded it into a huge amount of complexity. But think about it this way, right? How much complexity does a character have? Right? How many possible characters are there?
Well, for what they call it, for letters, it's no, it's more than even 26 because 26 times 2 because of what they call it, small cases and lower cases and upper cases. So that's 52, and for numbers is what they call it, 10. So that's 62.
Yeah, fair amount of complexity. Keep in mind, there's also the salt that's been added here, which has also added some complexity.
Oh, okay.
Right?
Wow.
So it's kind of interesting,
Oh,
right?
it has done the salting too?
Hmm?
Oh, it has done the salting too as well.
Oh yeah, it's salting.
Okay.
Absolutely. Like salting is now absolutely standard practice. So we're kind of in this interesting situation, right? Because like most people won't use a password that's over, 15 characters, right? So we're now in a situation where, our space of things we're hashing is much, much smaller than the space of things we're hashing into.
Ignore this.
Right? Which you can do because you don't need to save memory for each one of these things. So because this isn't a hash table, this works. But so there's our computed hash. If we take a look in our Soiba, what did I forget to do? Yep, I forgot to pass the hash. So
So the fact it should be hash and stuff.
I forgot to do the thing I told you to do. There we go. Gets me every time.
We're only leaving.
You know what, if I'm in there anyway, I'm gonna insert that break statement. There we go. So I'd just like to point out, right? I reloaded the page. Did my hash change?
Oh, I can't tell.
It didn't. I'll just tell you. It didn't. So, if we take a look at our database now, I actually have 2 entries for Squidward. I'll delete the one. But you can see that the hashed password has now been placed inside my database. Very good. Let's delete the old copy. Any questions so far? Yeah.
So I'm pretty sure on all of them, like it starts out $2Y, $10, $.
Okay. Probably some reason, some mathematical reason. I'm not sure. Let's say even without those like 5 or 6 characters, you've still got like 55 characters of entropy, so pretty secure, yeah.
Because each one of those characters is, how many characters can you enter into like that one spot?
Yeah, I think it seems to be pretty permissive of symbols. So like you're probably looking at like every face value on the keyboard.
I think other than like the space characters, I think every other character other than that.
Maybe.
Can this spit out a space character?
Probably it restricts itself to printable characters for like ease of use in databases and checking and that sort of thing. Because if it was like, it's super easy to generate like a bunch of unprintable characters, but like if you stuck to ASCII, you know, there's like, you know, 210 printable ASCII characters, you know, so it's a lot of characters.
Oh, I see.
So let me just add a couple more. Mr. Krabs, 1, 2, 3. Password is money. There we go. And now you can see that is a different hash value.
Except for table.
See?
So this closes.
2 different hash values.
Let's think.
Although, yeah, again,
Oh, the correction word.
$2, $Y, $10, $. That does seem to be like a prepended front code. I'm not sure what it means. We'll see. So now, let's modify our login script so that we can check our password. So, remember the previous way that we were validating, whether or not the username and password were in our database. We were relying on SQL to do this work for us, right? Our ingoing query was select all from credentials where username is equal to user and password is equal to password. The username and password which were entered. right? In the post request. We then counted how many rows were returned, and if precisely one row was returned, we know that there's one row in the table that has that username and that password. Therefore, we have a match, and we provide login. Okay. There are two different ways that we can approach this. The first way is to just compute the hash, send that through to the database. So, oh, wait. Stop. Up here. Again, compute the hash. Password hash. P. And then, rather than providing here, P there, we provide the hash, where we are inserting it into the SQL query. Right? Yes.
Doesn't the password hash give a random result every time?
Oh, no, it doesn't get a random result every time. It looks up the previously entered passwords and looks up the same salt that it used last time for the same password.
So it stores password and the salt associated with it?
In Apache. In the Apache server, yeah. Because otherwise, the whole procedure wouldn't work. If it was a new salt every time, it would be a new hash value every time, and that would break everything. Yeah, that's a subtle point, and I hope everybody gets that point, because I imagine there'll be a test question on it, on the exam.
What question is that?
Ooh, did I say the word test? Understanding that you don't generate you don't generate a new random salt for a password every time. Like, that's critical to understanding the whole thing, and it would make a good that would make a good exam question, in my opinion. So, anybody see any problem with this?
You forgot the password default.
I forgot the password. Which? Password T. Oh yeah, right. It's what is it? Password default. Yeah. Thank you. Password default. There we go. Can anybody else can anybody else sniff out some potential problems? Yes?
So basically, like, oh, this is for login.
Yeah.
It's to get the username and to get the password. So to get the username and to get the hash. But if I'm not sure if I use, well, what if I now? Does that mean I'll have to log in with the hash? Or I can log in with my passwords, like my regular password still?
Log into what?
Like, so log into the account.
Oh, the user will still have to enter the same password they entered to register the account on their end, right? The user does not have to enter the salt. That's kind of the whole point.
Okay.
Yeah. So, let's see if it works. Login, Mr. Krabs, 123. Password is money. Bad credentials. And different hash.
Oh, and I looked it up, the question marks, or the money sign at the start is, like a separator, like a field separator.
Oh,
And it just tells you, like what hash was used and the cost of it, which is
Oh.
by default 10, so it's 2i and then 10 with $3 in it.
ah. Gotcha. Cool. So, yeah, I figured it was some kind of metadata stuff.
So if we kept on refreshing the page, isn't there like a slight chance that it would work out? That the algorithm would spit out the same hash twice?
Infinitesimal, but yes, there is a chance. So,
Like the type of fonts now.
I just use my so I just put that in one property. I keep those on
okay,
This whole thing.
I'm gonna do a couple of things.
the like first.
You know, when you asked us if we saw anything wrong, I was like, oh, there's definitely a bug that he knows about. Okay. I'm glad I couldn't catch it.
I like to keep you on your toes.
Yeah.
Why are you making password text?
I am making password to text. Oh,
Honestly.
they are getting different.
Yeah.
Why are we getting different hashes? Password hash, you're not performing your duties correctly. Oh man.
So close to the whole thing.
Maybe it's something to do with password default, maybe because it's default generating an entirely new one.
Maybe. I don't think so though. Alright.
Oh, there. It's a while. This is loading.
Okay.
Did you change the font name?
Let's pick a font that we feel comfortable with. Nice. Just like this.
He doesn't care about which font I use.
Alright, anything specific?
Mm. Okay.
What's that?
So, here's the issue. I didn't know what error we would like hit in order to bring in password verify, but I knew we would hit an error eventually. So basically, there's a separate function
Just say table.
for checking a hash value as opposed to generating one.
Or table.
Password hash generates and password verify checks. So,
Oh, so you're just checking for equivalency, but you're not using the function? Is that what you're doing wrong?
Password hash function creates a new hash every single time.
No, I understand what that does. I'm asking,
The
are you
verify.
getting an error because you did not use verify?
Correct.
Okay.
Yeah. So, let's check the documentation. So, verifies that a password matches the hash. Verifies that the given hash matches the given password. Compatible with crypt. All the wait. No, see that, okay, so, literally all it's doing is just checking. We'll try it. But, so the hash which is being pulled from this guy is
But in this context, you're not getting the password back because your query would not return it, or because you would not have an equivalency to check for it. You get what I'm saying?
Mhm.
You would have nothing to test it against, because you can't look up someone else's password, you can't confirm that they're identical on the server.
Well, you can look it up by username.
You could look it up by using it, yeah.
Yeah. Yeah, you can just fetch what the password is by username. So that would mean just where name is equal to username. And then we remove the hash here.
Yeah.
But see, the problem is it's supposed to generate the same one each time. Like, hashing should be stable. It's doing something with the salts. I don't know if it's because it's running on an XAMPP server. Like,
So all the, that one, I don't know anything about this.
let's call this test. Okay, I'm running a test.
After passing it through the password hash, right? Database password. That's cost. Yeah, but you can't. So the first thing is that's a useless function if you're passing it to the database. As the password.
Oh, I mean like the other kind of people have stuff like
Create database,
So I don't get based on other things that has that. I guess that's the one. So.
So it should not be, and that's why he's.
it's back, it should be just
Hashes.
You
never know.
Yeah, it should just be.
Like you never know. That's why I guess that's the one.
To do more than that would be something.
So as long as all the tags are met, then this is fine.
It's all.
Alright, let's try this.
Because then there's also the problem too, if you fully merge this, you're giving Bill access to like modify all value. But I guess they're.
This table, maybe you have here like agency that people need to change.
Yeah.
Yeah, of course.
And this one. So this one, if it has these all, it has those. It's because HG has these right away.
Okay.
The table thing.
Well,
and then X, and
I'm
then
gonna have to do
So that's
some
why I have this
investigation,
or
but
this.
that's not what I expected the behavior to be. Something
It's
must be
secure
wrong.
enough to like stop you from hacking it, like it's pretty
And
good.
then that's cool.
So-
It's secure enough to help to prevent all useful anything to happen. That's how secure it is. There's a video game called Mother 3, and the big bad guy
Should say not balanced.
in that game is like Porky, yeah. He's like, okay, you've defeated my ultimate robot, and now I am going to put myself in the absolutely safe capsule. It is so safe that he can never leave it, and he can't in any way affect the outside world.
Right.
So you just walk by him, and that's like the second to last
It's
boss
missing a
of
lot
that
of things.
game.
So they just put themselves in a confinement chamber?
Which one is this supposed to be missing?
Yeah, and it's like they're making faces at you through the window.
Isn't it?
Oh, yeah.
It doesn't have, yeah.
I just find it super funny because I just imagine like later leaving and they going like,
You did
what now?
Modulus too, right?
Yeah, it's a weird game. It's a weird game. Anyway, all right. Thank you very much, folks. We'll resume this tomorrow, and we'll bring. I will bring the tests. Yeah, I got it. Okay.